Hello everyone, welcome to Zarif Game Dev, and in this video we are going to create the Orbits game in Unity. So it's a simple hyper casual game. You can create it as a beginner, and in the previous video created the dot rescue game. So we are just going to use the same principle here. So there'll be some rotation for our objects, and our players just going to have changed radiuses. So it looks pretty simple, but as a beginner, it could be a little bit complicated. So let's see how the game looks. So there are three obstacles, and both of them have the same orbit. And our score spawns randomly at one of the angles, and our players going to have the rotation movement and the changing movement, and the speed is going to be variable depending on whichever orbit or the radius it is. So it is almost pretty much simple, but added a little bit of more functionality. So if you want to get the projects or video, you can directly get it from the YouTube and my GitHub link below. And if you want to support the channel, you can donate it on my Patreon, or you can buy the whole course on my Udemy. I put the whole course on the Udemy, and the whole thing, every video is going to be posted on YouTube. So don't worry much if it is on Udemy or not on YouTube. So thank you guys, and if you are going to complete the whole game, do watch the whole video, and let's start creating. So let's set up the project first, and we have an empty project in which we just have the sample scene which we are going to delete it later. And let's start by changing our build settings. So the first thing we'll do is switch our platform to Android, cause we don't want to use a couple of packages which are for Windows, Mac or Linux or whatever build you are using. So we'll switch our platform to Android first, and after that we'll go inside our project settings, and we'll import TextMesh Pro. So it is going to be directly imported from here, and inside our time we are going to set it to 0.01, so it is a little bit slower, so the movement will be smooth. So as you can see, let's disable the warning for TextMesh Pro, and for our time we are going to set it to 0.01. And inside toolchain management, previous time we turned it off, so it is already turned off. And we'll need to change the script execution order, which we'll do later. And after that, let's set up our packages. So there are so many packages, and we just need only four of them. So let's remove the rider editor. Then we'll remove the test framework. So it will take a couple of seconds. And let's remove the test framework and also the version control and the visual scripting, and finally our VS Code editor, cause we are using the Visual Studio. So we'll use the Visual Studio editor. uh, so almost all packages will take around 20 to 30 seconds. So let's remove visual scripting, and finally we'll remove our VS Code editor. And our Visual Studio editor is previous version, so let's update that for this project. And package manager is done. We don't need the build. We'll need the build settings. So let's first delete our sample scene, and before that we'll create both of our scenes. So our first scene is going to be called main menu, and whole main menu is going to be similar to the first game. So If you want to skip ahead, you can directly skip ahead to the gameplay scene, and again we'll create new scene. And before that, let's add our open scene and remove our sample scene. And this scene is going to be our gameplay scene. So we have both of our scenes and both are added to the build. So we'll close our build and we'll need to change the script execution order. So for that, we'll need to create all of our scripts first. And if you are creating a new project, you won't know which scripts you'll be using. So it would be better to do it later, but we'll change script execution order, and for that we'll need to bring in all of our assets. So first we'll bring in the editor, which is going to have our colors, which are just these three colors. One is the light one, the black one, and a little bit for the highlight, which is lighter. And after the add, we are going to bring in our resources, which includes all the fonts, images, and the sounds. So there is a click sound, the loose sound, the move sound, and the point sound. An update won't be necessary, but it doesn't matter. And after we have our resources, we'll need to create one more folder for our prefabs and another folder for our scripts. So prefabs we haven't created any right now, but we'll do that in our gameplay scene. So let's create all of our scripts. So the scripts which we are going to need is first of all our game manager. Then we are going to need our gameplay manager. And after we have our gameplay manager, we are going to need the main menu manager. And then our sound manager, and obstacle score, and our player. So just three more scripts. So the first one is for the player. It's going to set the movement for the player, and then we are going to have obstacle. It's also going to have some movement, and finally the last script is for our score. So let's go inside our script execution order, and the only script execution order we need to have is the game manager at the start, and let's set the sound manager next, obstacle, player, and score. So it doesn't matter whichever order it is. So let's have the player at the higher position. Score and obstacle board doesn't matter, they are going to have their own individual movements. So that was it for the settings, and let's apply our script execution order, and we should be able to see our current game. So it is open inside an iPad. Let's use iPhone 12. So that was the project setup, and in the next part, we'll create the sound manager. It's the easiest script, and mostly we'll create the main menu, and then we'll see what we need to do next. So we have set up our project. Now we'll start by creating the basic layout for our main menu. So let's first set the background color of our project, which is going to be the black, and let's use the ratio for our portrait, and let's see what we can do first. So let's add a title. So we'll call this title, and the title is just orbit and orbits, and we'll push it to the center, and it's going to be from the top 0 negative 384, and size is going to be 10 to 4 by 512. And for the font we are going to use our font which we have used, and the size it's going to be 256, and let's make it bold. Yeah, and as you can see it is not fitting, so let's set it to set up our canvas. So we'll use screen space camera, and we'll have to scale with screen size. So the X is going to be 1080, and we'll have it match the width. Let's just use 10 to 4. Again, it's okay. It needs to be a higher 10 to 4, 1080. So now it looks a little bit better, and let's set its canvas to match width. Hmm. Let's decrease it a little bit. So this is our title, and we can just use orbit. Yeah, that's better. Maybe we'll need to use orbits. That is filling the whole screen. 240, and let's set its color to our dark color. And after we have our title, we are going to need the play button, which is again going to be an image, and the image size it's going to be 256 by 256, and it's going to be positioned a little bit higher. So let's have it at 192, and the sprite we are going to use is the circle, and the color we'll just use white, but a little bit transparent. Okay. Mm, let's just use the white one. And we'll attach a button component to it. Let's set the color tint to none, and we'll add our play button, which is going to be 256 by 160. Let's position it 8, and let's set its color to the green one. And after that we are going to have one more text, which is going to be for our score text. So let's add UI text, and we'll call this score, and our score is going to be positioned from the bottom at 800. Width is going to be 10 to 4 by 512. Alignment is going to be center, and the color is going to be dark one. Let's add a random number so we can see how it's going to look. And the font is going to be our own font, and the size is going to be 128. And after that, uh, hmm, so that's going to be a font. And similarly with the score, we are going to have the high score, which is going to be positioned at 288, and the color and everything else is going to be similar. And let's add one more UI text, and we'll call this new best, and it is let's just duplicate our score, and we'll call this new best, and instead of text we'll add new best, and its size is going to be 96, and color we are going to use is our bright color, and let's position it at 640. So as you can see, it is below our current score. And similar with our new best, we'll duplicate it and we'll just rename it to best. And instead of new best, it will just call best and we'll position it at 128. So that's how simple our starting screen is going to look. And after that, we'll add all of our managers. And let's see if our display works fine in all resolutions for the portrait mode. So it is looking good. 18:16:9 portrait, so everything's fine. And let's start adding our main menu manager, and let's reset its transform and we'll attach the script. And similarly we'll add our game manager, reset its transform, and we'll attach our game manager script. And finally we are going to add the sound manager, reset its transform so it is always at the center, and let's add the sound manager script. And finally our audio source component, cause it's going to need to play all the sounds. So that's just going to be our basic main menu setup, and we'll start scripting in the next part. And let's see. So we have our main menu manager setup, and now let's just code our sound manager. It's going to be the simplest script, and let's see what we need to do. So first we'll need a public static sound manager instance, and we'll set it up inside our awake function. So we'll check if our instance is equals to null, that means there is no instance. Then we'll set our instance to this, and we'll set the don't destroy unload to the game object, and we'll return. Else what we are going to do is we'll just destroy our current game object. And it's just going to have one function which is going to be private audio source, and we'll call it effect source from which all of our sounds are going to play, and it's going to export a method to play the sound. So whenever we want to play sound, we'll call sound manager dot instance and dot play sound. So we'll just use effect source dot play one shot, and we'll pass an audio clip which is going to be our clip, and we'll pass it as a parameter. So pretty simple, nothing too complicated, and yeah, just took less time. So let's go inside Unity, and let's add our audio source to the sound manager. Now similarly our game manager is going to be simpler. I thought it would take much more time, so let's also code up our game manager. So let's go inside Visual Studio, and we'll open our game manager script. So as you can see, it's opened up, and we'll start coding our game manager. So everything is going to be similar in the as the previous dot rescue game. So if you don't want to uh, code it again, you can directly copy paste the code. And so let's see, first we need a game manager instance, and inside an awake, if our instance is equals to null, then we'll set the instance to this, and we'll use don't destroy unload on the game object and return, and we'll also need to initialize the function. Else what we are going to do is we'll just destroy the current game object. We don't need to do anything. And let's create our init function, and in our init we are going to set up our variables which are going to be the initialization. Public bool is initialized, and let's have a getter and a setter, so it will automatically create for us, and public uh, int for our current score. And similarly, it's going to have a getter and a setter, and what it will do is will set is initialized to false and our current score to 0 when our game starts. And that's just going to be for our initialization. And we are going to have one more variable which is going to public int high score, and in our high scores getter what we'll do is private string high score key, and it is just going to be the string high score, and we are going to get it from the player prefs. So we'll return player prefs dot get int, and we'll pass our high score key, and if it does not exist then we'll return 0. And similarly inside our setter we'll use player prefs dot set int for the high score key and whatever value it is passed, so it will return us our high score. And there are going to be two more functions, so private const string, and first one is going to be for the main menu, and depending on that name we'll load our main menu, and we'll duplicate, and one more string is going to be for our gameplay. So as we are just using it once, it doesn't matter, but if you want to use main menu again and again and again, so the autocorrect won't show up the correct name, so that's why we are using as a variable. And it's going to export two functions, and which is going to be public void go to main menu, and what it does is just loads our main menu scene. So Unity engine dot scene management dot scene manager dot load scene, and will pass our main menu, and similarly inside our go to gameplay will pass a load scene for our gameplay. So as you can see, the game manager is also pretty simple, and we'll use both of them when we click the button. So at the start we need to show our current score, and if the game is just finished, then we'll animate our current score, and that we are going to do inside our main menu manager. We'll also need to show up our high score, and so game manager does not have any parameters. We also set up our sound manager, and let's hit play to see if we had any errors in our scripts. So currently it's not showing any errors, so everything's working perfectly fine. And in the next part we'll start coding up our gameplay manager. So we have added the game manager, so we can get the current score and the high score from there. And when the game starts, we'll see if our game manager is initialized. So if it is not initialized, then we won't show the current score, but we need to show the high score. And if it is initialized, then we'll animate our score. And if we set up a new high score, we'll show our new best, which is going to be this, else we'll just hide it. And we'll attach the play button, which is just going to be the scene transition function, and it's going to be inside our main menu manager. So let's start coding our main menu manager, and we'll load it up. So as you can see, it is currently empty right now, and what we are going to need is a serialized field and private tmp text, and the first text we are going to need is our score text, And similarly, the next text is going to be our high score text, and one more text is going to be best score text. mm, okay, new best text. There is no need for score. So inside our awake, we'll first check if our game manager is initialized. Game manager dot instance dot is initialized, and if it is initialized, then we'll start the coroutine, which we called the show score in the previous game, and it is completely going to be similar. There's not going to be any changes. So let's set it to high score and new best, capitalize it. Else, what we are going to do is score text dot game object dot set active to false, and similarly new best text dot game object dot set active to false. We don't need to show both of them. And our high score text dot text is going to be game manager dot instance dot high score, and we'll convert it to string. And what happens when we the instance is initialized, so we are going to animate our score, and we'll need to create an enumerator, private enumerator, and it is going to be show score, and we are not passing any parameters, but let's have it not return any errors, so we'll just use the return null. And that's what our animator is going to do for now. But before that, let's create our button function. So for the button, it's also going to play a sound, which is going to be our audio clip, and we'll call it click clip. And our button function needs to be public, and we'll call it click to play. And first, what we need to do is play our click clip, and after that we need to go to our gameplay scene. So we should be currently inside the main menu, and after that it will take us to the gameplay scene. And let's see if everything's working perfectly fine. So let's go inside Unity, and currently our counting function is not doing anything, but let's add all of our references so there are not any errors. So let's add the click clip, the score text, the new best text, and our high score text. And now it should not show any errors, and there should be some high score. So there's an issue with the high score. Maybe we didn't set it to false. Everything is turned on to true, new best, and score. So let's see. Our score is here, and score dot game object dot set active to false, high score. Okay, so that was the issue, the high score, and our new best is going to be here. So let's see if everything works fine. So as you can see, our current score is 10, and if we attach our play function, so let's add our function, which is going to be click to play. We should be able to go to the gameplay scene. So as you can see, we have gone inside the gameplay scene, and next thing we need to do is animate our score, and we have already done it in the previous video, so previous games video. So it's completely going to be similar, the whole function is going to be similar. Maybe the variable names would have changed, but we'll code it up again, so it will be good practice. So let's see what we are going to need. So serialize field private float, and we are going to have animation time, and serialize field private animation curve, and we'll call it speed curve. So whatever speed it is going to be using. And are we going to need the Unity Project Explorer? Let's hide it. And inside our show score, let's set up our score first. So temporary score is going to be 0, and we'll set our score text dot text is going to be temp score dot toString, and we need to get our current score, which is going to be GameManager dot instance dot current score, and also our high score, which is going to be GameManager dot instance dot high score. And if our current score is greater than high score, then we need to show the new best text, set active to true, and after that we need to set also our high score. GameManager dot instance dot high score is going to be our current score, else we are not going to show our new best text. And finally we'll show our high score. So high score text dot text is going to be from the game manager dot instance dot high score dot toString. So it should show us our high score. And finally let's animate our score. So let's speed is going to 1 divided by animation time, float time elapsed is going to be equal to 0, and while our time elapsed is less than 1f, time elapsed plus is equals to speed multiplied by time dot delta time, and will yield return null. So this function is going to be called every frame, and depending on that we'll set our temporary score, which is going to be casted to an int, and what we are going to pass is a speed curve dot evaluate, and we'll pass our time elapse, so it will be value from 0 to 1, and we'll multiply it by our current score. And finally we'll do score text dot text is going to be temp score dot toString. And when the game finishes, our temp score is going to be equal to current score, and similarly we'll set up our score text. So that was just the animation part. All we need to do is set up the animation time and the speed curve, and it will be done. So let's go inside Unity, and for our main menu manager, let's use the speed curve to be fast and then slow, doesn't matter whatever we use, and let's set the animation time to 1.6. And for now we won't be able to see it animating, but afterwards when our game has some score, it will animate to the current score value. So that was it for our main menu, and if you want you can directly like copy the whole scene and export it and do whatever you like, or just copy the scripts, and most of the scripts are similar, there are no any name changes. So that was for the main menu, and the next part will set up our gameplay, and we'll see what we do from there. So we created the main menu, and let's start creating our gameplay scene. So let's hit play, and let's see if it's everything's working. So the sound is getting played, the button is working. Now let's go inside our gameplay scene. So for our gameplay scene, let's start by changing our camera. So our camera is going to be the dark color, and its size it's going to be 32.4. And we need to create a UI which is just going to be showing our score, and we'll just call it score. And canvas, have it to screen space on the camera. Let's attach our main camera and have it scale with screen size and match the height. So, and for the score we need to set its position 10 to 4 by 5 and 2 from the bottom at 128 and position to the center. Let's add some random number, and for the font we are going to use types of font, and the size let's have it 128. So that's where our score is going to show up, and let's make it a little bit bigger. And let's now create our background. So our background is just the three lines which we see, uh, the orbits, and we'll create it using the previous game method where we created circle inside circle. And let's create an empty, and we'll call it BG, and we'll reset its transform, and caps lock is, and here we'll create one more empty, and let's rename it to BG1. And just so the naming convention goes perfectly, let's go inside editor and use underscore. So when we duplicate it, it will be renamed to BG2. And we'll need to attach a sprite renderer, and for our sprite we are going to attach the circle sprite, and its size is going to be 24.4. And order in layer we are going to start from -20, so it is going to be at the bottom, and as it increases our ordering increases, and its color, it is going to be our dark color. Now let's duplicate that BG2, and let's add 23.6. Let's have it at -19, and let's change the color to our background color. So as you can see how it is going to look, and let's duplicate it again, and this time the size it's going to be 16.4, and the ordinary layer let's set it to -18, and the color will change it. Duplicate it again, change the ordinary layer to -17, subtract 0.8, so it should give 15.6, change the color to black. And similarly we'll create the last ring, which is going to have the size of 8.4 and order in layer of -16, and the color is going to be the dark one, and final one is going to be -15, and let's have it 7.6 by 7.6. So as you can see, this is our background. And after that, let's start by creating our player. So our player is also going to be pretty simple. So let's create an empty for the player, and we reset its transform, so it is going to be at 0 0, and its it's not going to have anything, but let's attach a player sprite. So let's create an empty and we'll call this, let's just call it sprite. And for our sprite, it is going to be positioned relatively at 400, and let's attach a sprite renderer first, and let's add our circle, and its size is going to be 2.4. So instead of simple, let's have it sliced, and let's have it 4, 8 and 12, 12, 0. So as you can see, this is our player. It needs to have our orange color, and similarly our player is need to going to have a rigid body 2D, and before that it's going to need a circle collider 2D. So, and for the rigid body, our gravity scale needs to be 0, and also it is going to have our player script. And finally, our trail, which is going to be a particle system. So as you can see, our particle system is looking almost okay. So let's add the materials, set the order in layer to 4. So it will be on top, but behind the player. And texture sheet animation, let's use sprite, and let's add our sprite. Size over lifetime, it is going to be decreasing, and color over lifetime, it is going to be transparent. And here maybe we'll need to change the color. So yeah, so this is going to be our current color. And shape, let's have it circle, and the radius is going to be 0. And for the emission rate over time, let's set it to 4. Now for the duration, looping to true, start lifetime to 1.2, and start speed to 1.7, start speed to 6, and start size to 1.6. And color, there was already the white color, but it doesn't matter. And the simulation space will need to have it inside the world space. So now it should look like a trail when it moves. So let's see if it is looking like a trail. So if we move our sprite, we should be able to see the trail. As we are moving pretty fast, it is looking bad, but you can see how it is going to look. So our particle system should be done, and that's going to be our player. We are going to attach mostly the player movement is going to be on the player script. So let's add the particle system above, and let's see if everything's done fine. Simulation speed, gravity modifier, nothing. Yeah, so that was our particle system. Now we'll need to create our obstacles. So there are going to be 3 obstacles, and we'll create them as a prefab. and we'll duplicate them in the scene. So let's create our first obstacle and we'll just call it obstacle, and let's reset its transform. So this is going to be our rotation part for the obstacle, and it is currently at 0, 0, and this needs to be at 0, 0. Let's save this obstacle as a prefab. So our current obstacle is at 0, 0, and after that we are going to have an obstacle sprite, and yeah, so let's create our first obstacle sprite. So let's create an empty and we'll call as obstacle sprite, and it is going to have a tag of obstacle, and we'll need one more tag for the score. And our obstacle sprite is going to have a sprite renderer with our sprite to be the circle, and color it is going to be 392565, which one it is, yeah, dark color. And after having our dark color, its size is going to be 3.2, and it's going to have a circle collider 2D, which is going to be a trigger and an obstacle script, and order in layer will need to set it to 4. So let's add our obstacle script, and let's create an empty and we'll call it center 1, and its transform is 0, but we'll need to attach a sprite renderer which is going to be a circle, and for our circle its ordinary layer is going to be 1 higher, so let's set it to 5, and instead of simple we'll have it sliced, and it is going to be of size 2.8, and its color is going to be our black color. So uh, when it is inside the gameplay scene, you'll be able to see how it looks, and our final is going to be our center just one dot, which is going to be 1.6 size, and the order in layer is going to be 6. Now this is our obstacle, and we have created as a prefab, and let's go inside of a prefab and let's see our obstacle. Why did it get deleted? Okay, so let's add our first obstacle and we'll rename it to 1, and for our obstacle sprite we'll position it at -4, and similarly we'll duplicate our obstacle 1 and we'll position it at -8, and our final sprite is going to be positioned at -12. So inside the game you are able to see that our obstacles are here and finally our player is here. And maybe we should position it at the right side. Maybe it doesn't matter. Let's position it at the right, so we are able to see how it looks. So that's where our obstacle is going to be, and for our player, for now let's position it at 0 and 4. We'll change it afterwards. So that was our obstacle. We also need to create our score, which is just a simple dot. So let's create that, and we'll save our score as a prefab. Hmm, hmm, hmm. So let's create an empty and we'll call it score. And our score is going to have a score sprite. And for our score sprite, we'll need a sprite renderer. And the sprite is going to be our circle, and its size, it's going to be 1.6. And ordering layer, it needs to be higher than whatever our background is, so whenever it collides, it should be hidden. And 0 is almost perfectly fine. Let's add a circle collider 2D, and it should fit perfectly fine on it, and it needs to be a trigger, and we also need to attach our score script. And it will have a tag of score. And similarly for our obstacle, it had a tag. It needs a tag of obstacle. uh, the collider needs the tag, so whenever we detect, we are able to see it. And similarly our score is going to have tag, and we'll duplicate, we won't duplicate, let's just create an empty, and we'll call it center, and let's attach a sprite renderer, and the sprite is going to be our circle, and color, let's make it black, 39 80 100. So what its color is 39. Okay, so this one is dark color. And our center is going to be 206, and ordinary layer, it needs to be higher, and for the size we are going to use 0.8. So as you can see, this disk is going to be our score, and this is our player, and these are our obstacles, and nothing else is going to be needed. This needs to have a tag of score, and our obstacles are going to have the tag of obstacle, and that should be it for our score, and we'll save it as a prefab and delete from the scene. So that's how our game is going to look, and in the next part we'll start coding up the features, and we'll also need our gameplay manager, which we forgot to create, and let's add the script, and let's do the coding in the next part. So let's start coding our gameplay manager, and our gameplay manager is going to be pretty simple. It's just going to have the game over function, and one more function to calculate the score and show it up here, and also the spawning of the score, which is just going to be a private function, which will be automatically called when the score is going to be updated. No update functions, and just initializations. So let's go inside our gameplay manager, and let's switch to Visual Studio, and let's see what we are going to need. So inside our gameplay manager, let's create a serialized field, private tmp text, and it is going to be our score text, and serialized field, private game object, and our score prefab. And private float for our score, and inside our awake we'll initialize our game manager, and our score is going to be 0, and let's have it as an integer, doesn't matter. And our score text is going to be score.toString, and will spawn our current score, which is just going to be private void mm, hmm, 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 hmm. Let's just directly instantiate it. So we'll instantiate our score prefab. Let's just use the function. I don't want to change how I coded it before. So what instantiate does, it is just spawns the score, and will call spawn score, and that's going to be inside the awake. Similarly, we'll need to have a public function to update our score, which we'll call it update score, in which we are going to do similar things, but instead of setting the score to 0, we'll set the score to increase by value 1. And finally, inside our public void game ended, we'll set GameManager dot instance dot current score to be equal to our score, and we'll start our coroutine for the game over, and we'll need to create that coroutine. So let's create private enumerator, and we'll call it game over, and inside our game over we'll return for 2 seconds, and after that we'll call the go to main menu function from our game manager. So pretty simple, nothing too complicated. And similarly, we'll code our obstacle, and our obstacle is just going to have our rotation, so it is also going to be pretty simple. We'll add the references later. Let's code up our obstacle. So let's create a serialized field, private float, and we'll have a rotate speed, and we'll need to rotate its parent transform, so we'll need to get a reference to it, and we'll call this rotate transform. And inside our fixed update, what we'll do is rotate transform dot rotate, and we'll pass our rotate speed multiplied by time dot fixed delta time. So it will just rotate, and we will need to create also our score function, which just reinitializes our starting position, as we don't want to set it up inside our game manager. So let's create an awake, and inside our awake we are going to have serialized field private list of float. It can also be integer, doesn't matter. And we'll call it spawn pose X, and serialize field private transform, and we'll call this center transform. So it is going to be any one of the orbits which is going to be defined by any one of the elements in our spawn pose X list, and also it is going to rotate randomly, which is going to be assigned transform dot local position. It is going to be v3 dot right, and will multiply by spawn pose X, and we need to pass random dot range from 0 till spawn pose X dot count. So it will give us a random element and will set its local position to that, and set a transform dot rotation. It is going to be quaternion dot Euler, and here we'll pass 0 0, and for the z value we'll pass random dot range from 0 till 37, and we'll multiply it by 10, so it will give us a random value from 0 till 360 f. And inside our public method for score added, if we directly destroy the collisions, then it will just destroy this game object, but our overall score is attached on our center transform, so we need to destroy the center transform dot game object. So this just going to be these functions, and let's go inside Unity and let's assign our references. So first we'll add our score text, which is going to be inside our canvas score and our score prefab. And let's see what we need inside our score prefab. So we'll need the center transform, which is the starting. And for the spawn positions, we are going to have 3 spawn positions, which is going to be 4, 8, and 12. And this center is different, and what should I call it? Not center. Let's just call it score and a slash sprite and a slash 2. And similarly, we'll need to fill out our obstacle, which is going to be obstacle sprite. And all we need is our rotate transform and our speed, which will set all of them individually. So the speeds are going to be 60, 90, and 120. 120 is going to be the least one, and hmm, hmm. Let's have it at 45. And inside our obstacles, we'll need to set up its speed. So this one is at 45. Our 12 going to be needed 45. Okay, so this one's going to be at 60, and our center one is going to be at 90. And we are also spawning the score, so let's see if there are any errors. So let's hit play, and as you can see, all 3 of them are moving correctly, and the score spawned in the 3rd orbit, and if it was fine, it will spawn again. And again, there's some issue with how score sprite 2. Okay, okay. So that issue is going to be a prefab, and we'll need to parent it so it doesn't go outside. And let's hit play, and now we should be able to see the score. And our player is currently not moving, so we are not able to see the trail, but as you can see, the obstacles are moving, and the score is getting spawned randomly at any of the three orbits and at some random angle. So in the next step, we'll start coding up our player, and finally that should be the last part. So finally we have our obstacles and our score spawning correctly, and what we need to do is simultaneously move our player and have it detect the collisions for our obstacles and the score. So if we collide with the obstacle, then the game should be finished, and we already created the function. And if we collide with the score, then our score should increase, and it's also going to be moving between the orbits, so we'll need to create a coroutine to change its local position. And also the rotation speed is going to change depending on the orbit. So as you can see, all three of them you can see as they are moving at similar speed, but we'll need to have them arranged correctly. And let's set it up. So we already have our player, so let's go inside our scenes and our gameplay, and we have our player script attached, and it just has this sprite. And for now its position, uh, we it will be at the Y position, and if we increase or decrease its Y position, we should be able to like see it changing the orbit. So if the local position is 12, then it will be in the third orbit, 8, then it will be in the second orbit, and we'll need to change its local position. So let's see how we are going to do it up. And let's go inside Unity, and let's open up our player script. So we have our player script opened up, and what we'll do is first we'll add an audio clip, and these are going to be for our move clip and our loose clip and our point clip. And after that, we are going to have a serialized field for our gameplay manager, and we'll just call it GM, and a serialized field for our private game object, which are going to be our explosion prefab and our score particle prefab. And score particle prefab. So those are going to be just simple explosions. We'll create that later. And can click. So whenever our player is going to be transitioning from one orbit to another, we'll need to check a boolean, and uh, we won't be able to click again, or it will just switch to the next orbit. We are only able to click when our orbit is not changing, which means our player is only rotating. So at the start, our can click is going to be false, and our level is going to be 0. But where is the level? Hmm, 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 hmm. Okay, so we'll need to do update and we need to check if we can click, and if our input dot get mouse button down of 0, then what we'll do is sound manager dot instance dot play sound, and we are going to play our move clip sound, and we need to start the coroutine for our radius change, and we'll need to create that coroutine. But let's see how we can rotate first. So private float, and we are going to have a rotate speed and serialize field private transform for our rotate transform. And inside our fixed update, we will set the transform dot local position to be equal to v3 dot up, and it is going to be in the y-axis, and we'll multiply it by our current radius, which we'll need to create it again. So let's just leave the current radius later. We'll need to set the rotate value to be equal to, yeah, that also we'll need to set it up again. So our rotation is going to dependent on the radius. So for the maximum we have the 45 degree per second, so it will take 4 seconds to complete one rotation. But for the uh, shortest radius, which has the 4 unit one, it needs just 2 seconds, cause the overall radius just decrease 2 seconds or whatever it may be. So we'll need to do that here, and for that we'll need to see how we are going to change the radius. So let's first add our start rotate radius, and our speed is going to relative to the start rotate radius, and serialize field private float and our move time. So when we click, how much time does it take to move? And serialize field private list of float, and this is going to be for our rotate radius. So what radiuses are allowed, and finally our private float for our current rotate radius. So whenever we are rotating, our rotate radius will be any of the values from that, and to store that we'll create a private integer for our level. So if we are on level 0, then it will be the first one, and if we are on level 2, then it will be the second one. But if the value is anywhere in between, our local position is going to be depending on that current rotate radius. So let's see how we are going to change the radius. Private enumerator, and we'll call it change radius. And the first thing we'll do is can click to false, and finally can click to true at the end. And float move start radius is going to be equal to rotate radius for our current level, and float move end radius is going to be rotate radius plus of level plus 1. But as you can see, it may go out of bounds, so we'll percentage it by rotate radius dot count, and as you can see, it is changing like start to end. So we'll need to have the radius start from 4, then 8, then 12, and then after 12 we'll need 8 again, and finally the level will be reset to 0 and we'll have 4 again. So it will be an endless loop from start to end. So we'll need to attach 8, instead of 4 8 12 we'll have 4 8 12 and then 8, and after that we'll call move offset, and it is going to be move end radius minus move start radius, and float speed is going to be 1 divided by move time, and our float time elapsed is going to be 1 divided by time elapsed is still going to be 0, and while our time elapsed is less than 1f, will increase the time elapsed by speed multiplied by time dot delta time, and after that we'll set our current rotate radius to be equal to move start radius plus move offset, and we'll multiply it by the time elapsed. So time elapsed is a value from 0 to 1, so it doesn't matter, and will then yield return a null. Instead of null, let's use fixed delta time, and yield return new wait for fixed update. And after all of this is finished, we'll need to increase our level. So level is equals to level plus 1, and we'll percentage it by our rotate radius dot count. And finally, our current rotate radius is going to be rotate radius for our level, so it just stays there. And depending on the current rotate radius, we are going to set our local position, is equals to v3 dot up multiplied by our current rotate radius, and our rotate value is going to be rotate speed multiplied by time dot fixed delta time, and our rotate value is going to be dependent on our start rotate radius and our current rotate radius. So depending on the start, we'll divide it by the current. So if our current rotate radius is smaller, then it will get multiplied by 2, but if our current rotate radius is larger, then it will get divided by 2. So it's pretty simple. So it will just help us set up the value, and we'll use rotate transform dot rotate, and we'll pass 0 0 and our rotate value. And finally we'll need to set our triggers. So on trigger enter 2D, if collision dot compare tag, and the first tag is going to be for our obstacle, and then we need to instantiate our explosion prefab at transform.position and quaternion.identity, and after that we need to sound manager dot instance dot play sound, and we'll need to pass our loose clip, and we'll need to call the GameEnded function and we'll return. And similarly, if our collision.compare tag and we have the tag of score, then we'll need to instantiate our score particle prefab at transform.position and quaternion.identity, and we'll also need to destroy it. So destroy after instantiating, and we'll destroy it after 2 seconds. And after that we'll do sound manager dot instance dot play sound, and we'll pass our point clip, and we need to update our score, and we need to destroy the game object, but here we need to destroy the parent, so we created the function inside our obstacle. So let's get the obstacle component, and here we'll add our score added, which should have been public. Okay, so not the obstacle, the score, and we'll call our score added, and let's use return. So we created a lot of code. We need to set up the variables correctly or there'll be some issues later. And mostly there should not be any problem. Now let's go inside Unity and let's set up the values. So our sprite is going to have, so let's add our loose clip to loose, point clip to point, move clip to move, gameplay manager to the gameplay manager. We'll need to create the two explosions. Our rotate speed is going to be from here. So here it is, I suppose 90, 45, 60. What speed should we use? So let's just use around 180. Yeah, 180. 180. The rotate transform is going to be our player. The start rotate radius is going to be 4. Move transform, let's just have it 0.64. And for the rotate radius, we'll use 4, 8, then 12, and 8 again. So whenever it goes back, it starts from 4. And that should be enough, but there should be an error for the explosion. So let's create our first explosion. We'll call it explosion and a slash orange, and we'll save this as a prefab. Let's reset its transform, and inside our prefab let's save it and let's delete it. And inside our player sprite, let's add our explosion as a game object so it does not show any reference error. We'll create both of those particles in a while, but let's see how our game works. So let's go inside main menu, let's hit play, and there's an issue. Assertion fail. Okay. Transform.rotate. I think we forgot to add the rotate speed inside our gameplay. So for the sprite, the rotate speed was 180. 4, 8, 12, and 8. Oh, we forgot to set the level to 0. Yeah. So let's go inside Visual Studio, and the parameters which we have not created inside the awake will need to set it up. So the current level was 0 and the current rotate radius was the start radius. So level is 0 and our current rotate radius is going to be our start rotate radius, so that's why there was the error. Now let's go inside Unity and let's go from the main menu and let's hit play. So again there's the issue with the color and we'll need to fix everything up. So color, doesn't matter if it is this color, but yeah, not this color for the particle systems color. Let's hide the sprite render. Okay, so what it did is if we just push this to white, uh, it was automatically set up inside our color over lifetime, so it won't be needed. And our click is not working, so why is that? So can click needs to be true at the start, so that was the issue. So can click was false. We need to set our can click to true and current level to 0. So let's now go inside Unity. Always there will be bugs, but it's good to fix them. Let's go inside main menu and let's see if our okay, so our player is there, but inside our player, as for checking, we turned on its sprite renderer. We are not able to see it. So let's go inside main menu and let's hit play. And okay, so it is working, but we need to destroy the player at the end. So let's use compare tag to obstacle. Let's use destroy the game object, and again 0.64 second is still too less. Yield return new, wait for fixed update, 1 divided by move time. So let's go inside Unity and for the gameplay and the player, particle systems fine. Let's set the move time to 0.128 and it should not cause any issues. Maybe you'll return you wait for fixed update. Let's go inside the main menu and let's fix all the errors. So the particle system error was fixed. Okay, so the game is ending now. We can also collect everything. So both the speed are almost similar. And we can also listen. And the only thing that's remaining is creating those two particles and fixing up our particle a little bit. So let's decrease its start lifetime, so let's have it 0.8 and lifetime, no, lifetime is just have it at 1. There is not going to be any starting speed, but we'll need the size of lifetime to be decreasing linearly. Emission rate over time, let's just have it at 6.4 and let's see how it looks. So now it's looking like a trail and we need to have our explosions. So let's go inside prefabs and inside our explosion prefab, let's attach a particle system and we'll go from the bottom and this one is going to be for the orange. So let's use our sprites default material. Ordering layer, it's going to be a little bit higher. So let's set the order layer to 10. The sprite it's going to be is our circle sprite, and color over lifetime there is not going to be any, but size over lifetime it's going to be mm, decreasing value, but not to the maximum, just a little bit towards 0.32. And inside shape, instead of cone, let's have it circle, and let's decrease it to 0.3. And emission let's set to 0, and burst, and let's have it 50 count, 25, yeah, 25 should be fine, but it doesn't matter. Let's set its duration to 2 seconds, lifetime to 2 seconds, size, let's leave it at 8. Speeded lifetime 1.6, and duration doesn't matter. Start size to be random between two constants 1 and 2. Color is going to be 39, the orange one, and emission is going to be burst for the 16, 25, doesn't matter, whatever particles. And we'll duplicate it, which is going to be inside our prefabs, and this was our explosion orange. We'll duplicate this, rename this to explosion white, and what it's going to have is just the color change to white, nothing too complicated. Let's set the emission to 16. So white is going to be when the player gets destroyed. So let's add both of them. Not both, we just need to add one. So our explosion orange is for our score particle prefab, and our explosion white is going to be for our explosion prefab. So maybe it will be different. So our score is orange, white, yeah. So orange is going to be our explosion, and white is going to be our score. And now it should be fixed, and let's go inside main menu, and let's see what we can do. So explosions are working fine, but they need to be changed. So the first thing we'll need to change is for the orange. So the orange, the speed needs to be higher, so let's set it to 15. The emission needs to be 25. The size needs to be changed a little bit, 1.6 to 3.2, and the lifetime will need to be higher, so let's set it to 2. Similarly, for the white one, the lifetime needs to be lower. The speed needs to be a little bit higher. Let's just have it low. And emission will have 0.4. Let's restart. Yeah, 0.4 looks fine. And let's see how it goes. Okay, so it is fine. And the game should be finished, and as you can see it is animating, should not be capturing, doesn't matter. So that was it for this game, and see you guys in the next one. Okay, so it is recorded. It was the largest one, and the bugs fixing doesn't matter.